Hello again. In this video tutorial, I'm going to go through how it is that you can have objects collide on your P5.js canvas. And I'm going to build from a project that I had previously, which is this project here. If you don't have it, you can go back to another video to see how it's created. There's a series of different little balls that I can create by clicking on the canvas, and then I can remove one at a time by just clicking on the remove button, and they're all gone. So the question has come up, how could I put both other objects, other types of objects on this canvas, and then how could I have them interact with these objects in a sense and collide with each other? So for example, if I was making a game, and I'm just going to use the example here where the balls are the enemies, and then I were to make a player, how could I make it so that the player would have to move around and lose if he or it crashed into one of the balls? How do we do that? And I'm going to start off by saying if what you're doing is that, if you're making a full-fledged game with lots of interacting objects, which you probably should do at that point, is go and invest in learning a physics library that gives you the math and the calculations to handle things like collisions and various interactions between different bodies. There are many of these that are available that you can use. One that I like a lot is called matter.js. Another one is called plank.js, P-L-A-N-K. And there are still several other ones that you can use. And these are all JavaScript libraries that you can connect with the P5.js rendering and drawing code. But you know what, in this simple instance, and certainly for my class, for most of you who are watching this, we're not going to do that, at least not yet. So I'm going to roll my own collisions, and they're going to be simple, and they won't do a whole lot, but let's see how it would work. All right, so first off, I'm going to get to the task of creating a second object on the canvas, and that object is going to be a player object that has to avoid the different balls that are bouncing around. Okay, so, and to do that, I'm going to come down here and just create another class, effectively. So we'll say function player, and let's see, I think that when we create the player, we'll create that player in the middle of the canvas. Let's see, let's do that. So let's go, we'll give them an X initial and a Y initial as parameters to be passed in, like so. And then we'll have this dot x, so we'll define a property that is the actual x coordinate of the player at any moment in time, but we'll initially set that equal to the initial position, of course, and then we'll say this dot y equals y initial, like so. And I think just in the interest of time and to keep things simple, let's from there on forward, let's see, what shall we do? Let's maybe we'll use key presses to change the position of the player as time goes on, just so that we can move it around the screen. And let's see how we would do that. I suppose this is probably not the best way to do it, but again, just in the interest of time, let's up here define, we'll go back here before I start defining my classes, so I'll just say function key pressed, like so, and inside here we'll say if, and now I'm going to have to look up how to get key codes in processing syntax. So back to the web, and let's say P5.js key pressed, and we'll look through the documentation. Let's see. So okay, so it looks like we can steal this right here. If key code equals left arrow, do something. All right, so I'm just going to take this code right here and shamelessly use it myself. Now, we could do a whole lesson on the equals versus just equals. And what's the difference? The equality of objects versus this, and maybe I'll do that. But at this point in time, let's just think of that as a more powerful comparison than that. All right, it's more exact, but there's more to it than that. Okay, so what do we want to do? So if key code equals left arrow, let's take the player's position and let's move it left. And if the key code is right arrow, then we'll take the player's position and we will move it to the right. All right, and it definitely is a better way to do this, but I haven't even made a player object yet, in fact, right? So I'm just we'll make one in a little bit. We'll just call it P for player, and we'll say P.x minus equals, and let's move the player by 3. Give him a fighting chance to get out of the way. And if it's this, we'll say P.x plus equals 3. So we'll move to the right. And then we need another, I think we need another else if. And so keeping with the structure, I prefer that, believe it or not. So I'm going to stick with that. And else if, and we'll say key code equals, and I'm going to assume that it's up underscore arrow. At least I hope that's the appropriate constant for that. And then we'll change the y coordinate. So we'll say p.y plus equals 3, sorry. And then we'll just take this code right here, put it here, and say down arrow p.y minus equals 1. All right, and like I said, there are certainly better ways to do this, but for the time being, I think this will suffice. If you're wondering what P is, P doesn't exist yet. I haven't defined it yet, but P is going to be an instantiated new player that's right here. We may have to come back yet and adapt this and add more to the class, but for the time being, let's go make a player and see if we can get it on the screen, moving around, and then we'll worry about the collisions. Okay, so back up to the very top of my code. And right here, I'm going to say var p, like so. And then I think I'll just create that inside setup after I make the balls. So I'll say p equals new player. And let's put them in the middle of the screen. So we'll say canvas. Let's see, I need to get a reference to the canvas, which I think I have. Var canv. Canv is the canvas. I think I can just say canv. I don't think I have to do canv.elt, but let's find out. We'll find out when we get there. Okay. Where was I? P equals new player. Canv dot width divided by 2, right, to put it in the middle, and canv dot height divided by 2 to put them up and down, like so. And we're not going to see anything yet, but let's just make sure there's no errors. There is. Undefined player, capital player is not defined at setup in 33. Okay, so new player is not defined. Let's see what I did wrong. Function ball, function player. This is capital. There we go. Okay, always good to check. Great. Okay, no player on screen, but let's go ahead and try to draw it. So now in the draw function, we have to decide how to make the player. And I think just to make it clear, I think we'll make the player a square since the balls are around, so you can distinguish. And rather than just drawing a square of arbitrary size inside of the draw function, in other words, I could, at this point I could just say rect, and I could say p.x, comma p.y, and then I have to come up with a length and a width. But I think because I'm going to be doing collisions later on, I really want to have a specific length and a width that's been determined for the player. So I don't just want to make this 30, 30, and then decide to go change the player later and have to readapt these drawing commands inside here. I think what would be far better is if I did something to the effect of p.w and then p.h for the height, for the width and height respectively of the player. And I'll have to go define those, of course, down in my player class. Let's go do that right now. So we'll come down to here and we'll say this dot w equals, I don't know, let's start off with 40. That might be a little big. Let's do 30. And this dot h equals 30, like so. And then I suppose we could put a fill just to, let's say fill is 0. So we'll make it the box will be black. And I think if we're going to do that, we have to do something with the balls as well, so they're not also black. So let's make them white. 255, right? And you can see I have some commented out code that was there previously from a lesson that I did, from video that I did, where I was dealing with colors. And I don't have that implemented right now. So the balls are just white. The player is black. Okay, let's see what happens. There he is. Okay, so I'm going to press some keys, and you can see it moving around. I'm hitting the left arrow now. Uh-oh. That's the up arrow. I got something backwards, right? And that's the down arrow. So that's no good. We'll swap those. And then there's the right arrow. So left and right work, but the up and down are backwards. So let's go back. I also think it needs to move by a little bit more. Otherwise, we'll never be able to get out of the way of anything. Yeah, of course. Those of you who are watching this were probably wondering when I was writing it why I didn't catch that before. It's wrong. Okay, now it's good. Let's change this to, I don't know, 10 maybe, so that we can really jump and move. All right, and here we go. Now, one thing that I notice immediately is that when I reset, and this has to do with how the drawing is made based on the positioning of the rectangle, but it looks to me like the upper left-hand corner of the player is what's cueing the positioning of it. So that's what's in the center of the canvas right there. I'm not totally sure that I want that. I think later on, as I'm thinking ahead, when things start colliding into this thing, I think I want the position of the rectangle, of the square, the player, to be understood as the center of it, not the upper left-hand corner. So I think to get the rendering to match up with the math that I'm going to do for the collisions, I think it would be appropriate to set the mode. Now, for those of you who know processing, you know how to do this. For those of you who don't know processing, this may not be totally obvious to you, but in processing environments, there's a rect mode that you can set. And right now, I think it's set to corner. I'm going to set it to center. That's just a little constant that you can pass. Oops. There we go. And that will cue it, will cue the rendering, the renderer to use these coordinates as the location of the center of the rectangle as opposed to the upper left-hand corner. So refreshing it, that looks a little bit better. All right, that's just going to bring the drawing of it in line with the collision math that I'm about to do. Okay, so if we put some balls onto the canvas, you can see there's absolutely no interaction between the player and any of the balls, right? But now I want to do that. Okay, how? So collisions are a topic onto themselves, and I could do multiple videos on how to do them. And like I said, if you were really getting involved, you should probably go and get yourself a physics library to handle the collisions for you. But a gentleman named Jeffrey Thompson has published a wonderful little ebook on collision detection. And it's written, I think it's written in the language of processing. My understanding is I think it's processing when written with Java, which is the original environment that processing was built for, I believe. And P5.js is basically just the processing environment ported over to JavaScript. But I think we can adapt this simply enough. You can see it's got a little demo on the front page where you can move around this ball, and you can see it's detecting collisions with all sorts of different shaped objects, right? And so this is a really fantastic site. And if you can't see the URL, because the video might be a little bit downsampled, right? Or let me just zoom in a little bit. You're not going to get that. So this is where I went. Let's say collision math from, and we'll paste in the URL right there. Always nice to do that in your code for a couple of reasons. Number one, later on when you're going back and you want to look where you got the information from, it's right there in front of you. Great. Number two, it gives credit for the work done by somebody else. And you know, if you're submitting this as an assignment for some reason, or just sharing it with the world or giving it to somebody else, that's a way of citing the information. So we'll put that right in there. That's your URL. Okay. So apologize for all the noise and the phone in the background. Let's go on. So let's kind of scroll through a little bit. If we go to the table of contents right here, you can see that there are several other specific pages that deal with the different kinds of collisions that you can have. And this is very complete. Like, for example, if you wanted to know how to collide a polygon with a polygon, right? You can try it here, and then the code that you need is here. This one is quite involved, as you can see. Right? Polygons, the algorithm for polygon collision is going to be one of the more difficult ones that you could ever have to deal with. Thankfully, you don't have to worry about that. But even if you did, because it's all abstracted away for you in these functions that you're provided with, you really don't have to dig into the details of the function to understand or to use what's happening. And I think that's why I'm so interested in doing this tutorial, is I want to show you how it is that we can take code and understand it just enough to use it, but not necessarily have to go all the way back to the original steps of the algorithm. That work has already been done. It's already been put together for you by somebody and shared with you. So obviously I want circle rectangle, which is here. So we'll go here, and this is basically the code that I'm looking for. I'm just going to check it out and notice that, it works from every angle. Right? I can hit the corner, I can hit the side, I can hit the bottom. And so I'm pretty confident in this. There's some setup to explain how it works, and then there's a full example. And the code that I'm really interested in is this right here, right? This block right here. So if we look at it quickly to understand what's going on, first of all, this is written for Java syntax, and so there are data types that are declared: Boolean, float, if is not a variable type. But there's float, Boolean, that's all you see here. Also, this is a return type for a function, right? This is the function, circle rect, an actual function. You can see return false, return true, so on and so forth. Those are Boolean values, so we have that Boolean prefacing the name of the function, and then we have declarations of variables, local variables inside the function. So if we go through and just kind of look at what's happening really quickly, we've got the function circle rect, which takes 1 parameter, 2 parameters, 3 parameters, 4, 5, 6, 7 parameters. So the function expects to get 7 inputs. And I think they're pretty obvious what these things are, right? This is the x coordinate of the circle. This is the y coordinate of the circle. This is the size of the circle. This is the rectangle's x coordinate, rectangle's y coordinate, width and height of the rectangle. And we have all of these properties in our own sketch. They've all been set, I think, with the exception of the radius of the balls, which is, I think, only drawn. I think the drawing code draws the balls as having a certain size, but the balls don't actually have that they don't own a radius. And I think I might go back and add that. You'll see. So basically, we can use this as long as we understand. If we take this function, we're going to have to change it a little bit. The floats and such have to become var in JavaScript, since there are no specified data types. But other than that, it should work as is, just the way that you see it. Now, if you want to dig deeper and say, well, what's going on? Yeah, this is a really interesting function. And if I had time, and you should, it's worth going through and understanding, what is this algorithm really doing? And Jeffrey Thompson has done a brilliant job of commenting it and breaking it into little sections so you can really understand what's going on. I think this is really an intuitive algorithm. This is a really good one to understand. But for the time being, I'm not going to do that. I'm just going to take it, right, and copy it. And then let's come over here and let's put this function. We don't need to see it immediately anywhere special. Let's just put it down at the bottom of the code right here. And if we were to run and load the page now, it would come up with all kinds of errors because the syntax is just not right. So we're going to have to, must adapt this to JavaScript. All right, we'll get to that in a minute. But before we do that, first thing I'm going to do is go back to my ball class. And let's see how the balls have any size defined whatsoever. So here's where the drawing of them takes place. And you can see I'm using 20 and 20 for the radii of the x and the y radii of this ellipse. And I think what I want to do is just change this to balls I dot r, and the same thing here, balls I .r, just so that the ball actually owns its own data, owns its property, has this radius defined for it, and then we'll come down to the ball class here, and at some point it can be really anywhere. So we'll say this .r equals, and I think it was 20. So we'll go like that. So that has no functional change in the code whatsoever. It just gives me this nice radius variable for the ball class that's now saved in the model, as we call it, the model of the ball, and I can refer to that anytime I want it, instead of putting it in my, specific to my drawing code. All right, so now let's come down here and let's adapt this function so it works in the context of JavaScript. So the first thing I'm going to do is just get rid of the Boolean, because this is now, remember, is the return type of the function. So a keyword function is all I can have now in JavaScript. But what this means is that when the function is done, when the function does its thing, it actually gives you back a value. It's a function that hands you a result, right? And the way I always explain this to my classes is because we often see functions that do something but don't actually return anything. That's common. And the first time you actually use a function with a return type, it can be a little confusing. So the way I always describe it is as following. Here's my analogy. It's sort of like if you and I were working together and I needed you to do something for me, and I said to you, hey, here, take all these financial documents that I have here, right? These are the company's records for all transactions for the last month. Here you go. You take them, and you're the accountant or something, and your job is to process them and figure out how much money we made. What did we net this month? And give me the answer. Give me the result when you're all done. Okay, so go off, do your thing. You're doing your own work. You're my function, so to speak, right? I call you. I say, please do this work. I hand you all the documents. You go off. You do the work. When you're all done, you come back with an answer. You say, we made $60,000 this month. Well, that's your return type. You returned an answer to me, right? So some functions do that, right? Just like in life. Now, the other type of function that we work with, I think more commonly up until now, is a function that doesn't return anything, which in Java always is prefaced by the word void. But in JavaScript, it looks the same as any other function. There's no differentiation there. So a function that doesn't return anything is still a function. It still does something useful, but it doesn't give you back anything. So that would be like if I said to you, we're working together, and I said to you, hey, take out the trash, or go turn on the lights or something, and you go and do it. But when you're done, you don't necessarily give me anything. You don't have a return value to give back to me. So the way, and I point that out because the way this function is written, this collision function, it's definitely written to give you a return value. And that return value is going to be either, if you look down here, true or false. Either you collide or you don't collide. And I think the return is pretty obvious right here and here. So the rest of the math that's going on, not so important that I understand exactly what it's doing, provided that I feed it the right arguments. But I just have to understand that when this function finishes running, if I feed it the inputs for a circle and a rectangle, if it comes back true, if it returns true, then I know there has been a collision. If it comes back false, there has not been a collision. And return as a statement is perfectly valid in JavaScript, as it is in the original language this was written in. So we can leave all this code as is. The only thing I have to do is go back and change this to var, change this one to var. All right, if else if, that's all totally cool. Change this to var, so on, and so forth. Got a couple more. Var, no. Darn autocorrect. Okay, and let's save that. Okay. Oh, here too, right. Even my arguments. In fact, I don't even have to preface those with, in fact, I shouldn't. Let's just kind of go like this, right? Let's see, yeah, okay. Let's get rid of that. So one of the really interesting activities that you can do as a programmer is to take an algorithm from one language and write it and bring it to another one. You learn a lot when you do that. Some things translate very easily, some things not so easily, and you have to end up doing quite a bit of rewriting. But this is an easy adaptation to make it work. in JavaScript. So I'm going to assume right now that this function does its thing. I'm going to take one look at the order of the arguments that I have to pass in. So I need circle, I need the x and y coordinates of the circle, I need the radius of the circle, and then I need the x and the y coordinates of the rectangle, the width and the height. Pretty standard, right? I must pass things in that particular order for this function to work. So what I'm going to do is inside my draw function now, this function, let's see, is called, the name of it is called circleRect. Okay, so to keep things somewhat neat and tidy, inside my draw function, I'm going to call a function called collide. Right? Just to keep things, so I don't want to put too much in draw. All right, so we'll put that right there. And then down here, I'm going to write my collide function. So it should be clear that collide gets called every time draw loops, and that's 60 times a second. So 60 times a second, we will call collide. What does collide do? It checks the coordinate of the rect. Well, it calls this function right down here. It calls circleRect, right, and looks for an answer. So it looks for a true or false return value. So we're going to say if, because remember, circleRect returns true or false. So we're going to say if, because that's what we're looking for, is a true or false value. So if circleRect, I'm going to have to put the arguments in there in a minute, right? But if it's true, then we're going to do something, right? And I think for the time being, we'll just say console.log. Let's do crash. Right, so if there's a collision, we'll log that. Otherwise, we won't do anything. And of course, we can shorten this. We don't have to say if it's equal true. We could just say if. And that's implied. Right? That's shorthand for, if you're saying if something exists, if it exists, it's true, if it's true. Right? Either one is fine, but I prefer that. Okay? Right? If circle, now, so what do we have to feed into this function? So if we only had one ball, right? If we had an object called ball, then this would be pretty easy. We would say ball.x, comma, ball.y, like so. And then I think the third argument had to be the radius of the ball, ball.r, right? And this again, I'm learning this by looking down here all the way at the bottom at the list of parameters for my function. So back up to here. So we feed these in. And then if I had a rectangle, I do have a rectangle, it's called player. So I could do p.x, p.y, and I could p.w, and I could do p.h, just like that. So good, right? But no, not so good, because I don't actually have an object called ball, right? Instead, I have an array of multiple balls. So I need to make it so that this function checks my player rectangle against each and every ball in the array. So that means I'm going to need to loop through the array, right, using a for loop, or maybe a for in loop. There are a couple different ways to do for loops in JavaScript, and I'll start showing you some more other ways to do, newer ways to do this as we move forward. But we'll keep it simple for now because there's enough new content. So if we write a simple for loop, we can loop through and check each and every ball, its x and y position, its radius, and so on and so forth, against the position of the players. We'll just consistently call this function, circleRect, for every ball, every element in the array, right? It's going to look something like this. So I'm going to, first of all, I'm just going to indent that code like so, and I'm going to say for var I equals 0, I is less than balls.length, I plus plus, like so, and open and close parentheses. Let's see, I need to close my for loop right here. Okay, this then changes to balls I. So we look at the ith ball, its x position, its y position, its radius. Now they're all the same radius, right? But in theory, I could make different ones of different sizes. And so I'm going to check for the ith ball. I'm going to call the function circleRect, pass in that information, pass in the information about the player, and then if I detect a collision, if the function down here returns true, then I'm going to print to the console.log crash, which is what you see here. And so that'll happen when I is 0, and that'll check the first ball in the array against the player. Then maybe there'll be a crash, maybe there won't. But then I will increment to 1, and so then we'll be checking with the next ball in the array to see if there's a collision between that ball and the player. Again, maybe there's a crash, maybe there's not. And then I will be 2, and we'll check that against the player, and so on and so forth. So that way we'll get to check each and every ball against the player object to see if there's a crash. All right, let's check it out. Do I think it'll work on the first shot? Let's see. I don't know. All right, here's the player. The player's moving. Let's make a ball. Let's put it over there. So immediately there's a problem. So I probably left some inappropriate code. Let's see. Line 68, reference error, ball is not defined. Line 68. Right. Because the array is not ball. The array is called balls. Right. Okay. Good. Very. How critical is it to have your console open, right, when you're running and you're writing JavaScript? In most programming environments, you just get an error right at the bottom of the screen when you're trying to compile or something. But in JavaScript, if you don't know about this console and you don't open it, you're just dead. You don't know what the problem is. So, all right, refresh. All right, let's try. Make a ball. Oh, good. Okay. Well, watch that console. Let's see if we get any output. We did have some crashes. Oh, yep. You can see the numbers running up, right? Right here. See, it just went up 20, 27, 29. All right, let me see if I can zoom in on that console so you can see it a little bit better. Here we go. Okay, so you'll see when a crash actually happens. Here we go. It runs up the number. Actually, several crashes are happening because remember that function gets called 60 times a second, and therefore within that 60th, within the time it takes the ball to pass through the rectangle, it actually registers as crashing multiple times. Right, so that may not be a behavior that we want. We might actually want to just reverse the direction of the ball as soon as we detect a crash, so it no longer, stays in contact with the rectangle. But at least you can see now I have the ability. Let's see, clicking here, I can move around and avoid. Let's see, do we get a crash? If we, right. All right, so let's make this all just a little bit more obvious so things look better. So I think what I'll do is when a crash is happening, I'm going to change the, I'm going to make a variable that detects that holds the color of the player. And so when a crash is happening, I'm going to change the color of the player to red or some such thing, something like that, right? So just probably not the best way to do it, but again, just in the interest of time, so I'm just going to say var, let's say CL equal, let's say CR for crash, right? So we'll say, no, right? And in other words, you're not crashing. This is going to be a Boolean variable. It could be 0, it could be 1. So right now it's 0. So then inside of my crash detection function, which here is collide, right? I'm just going to say, so I'm going to stop logging those things. I'm just going to say CR equals 1, right? That means we're crashing. We'll change that Boolean variable to that. Otherwise, else, I'm going to put it back to 0. So if it doesn't detect a crash. Okay, so that will flip back and forth. And then what I'm going to do is cue the color of my fill, the fill of my player off of this particular value, 1 or 0. And I can just do that right down here in draw, so wherever that is. You start to say, at some point, you start to realize why you put different parts of your script in different files. You start to need multiple files because this is starting to get a little long and unruly. I'm searching around to find different parts of the code that I want to get to. So I'm looking for a draw function. Here it is. So instead of fill 0, I'm going to look at the value of that particular variable. CR. I'm going to say if CR equals 0, right? Then I'm going to do fill is 0. So we'll keep it black. Else if, and I think I could probably just do else here, right? Yeah. Else we're going to do, or actually, let's do this. This feels better to me. Fill is 255, 0, 0. If it's 1, make it red. Else, make it black. That's a better, it feels better. Okay, so let's see what happens. All right, here we go. Move the player around. Let's click to add a ball. Uh-oh, oh no. Try to stay away. Oops, I can't. Oh, there he is, red. Beautiful. It totally, completely works, right? Let's move him around. Let's put some more balls on the screen. All right, let's try to avoid him. Oh no, please don't hit me. Please don't hit me. Please don't hit me. For some reason, it's not turning red again. We've got to figure out why that is. Let's see what's going on. It worked once. Here, let's put some more. Oh yeah, maybe it's just not getting hit. No. Interesting. It's not always working. Why is that? So let's see. I think what's going on is there's something wrong with my little algorithm here for changing the color of the balls based on the collisions, and this is a good example of how you have to troubleshoot these things. Yeah, I see what's happening. So as I'm looping through the array, this is in the wrong place. So I'm checking each ball for a collision, and then I'm setting the color effectively to red. That's effectively what this is doing by setting this variable equal to 1. And if I don't detect a collision, then I'm sort of resetting it back to 0. But you know what? As I'm doing this individually for each ball, so as I go through the array, if the last ball in the array is not colliding with the rectangle, then I'm setting this back to 0, right? So in other words, and I think probably some kind of picture would be warranted here to sort of help. So let me try drawing something, and I think we'll make this point loud and clear. So let's switch over to a whiteboard here, and I'll show you sort of what's going on. So say for a minute we have this array of balls, right? I'm just going to represent them graphically with circles, right? So there's one of them, there's the next one, there's the next one, there's the next one, and there's the next one, right? So we'll put commas in between them like so. Those are not zeros. Those are actually the balls in the array. Very visual representation of what we have going on, okay? So I have an array with 5 balls in it, like so. And then I have my rectangle, so we'll draw that over here, like this. That's my rectangle. That's my player object, right? And so remember how the indices work in JavaScript, like commonly, like in almost every other language, is that this is the I value. So you say, what is the value of I? So right here, this is I. So this is the 0, this is the 1, this is the 2. You know, they're in line with the 3, and then this is 4 right here. So there are 5 balls, but this one is the 0th. This is the first. So we say JavaScript, arrays are 0 indexed in JavaScript. Okay. So the way my algorithm is written, right now, is with the CR variable, the Boolean variable, set to 1 here if I detect a collision with any one ball, and then reset to 0. What it's doing is it's taking the first ball, so that's this one right here, right, and it's sort of taking that one, it's pulling that one out of the array, and it's comparing it with this, right? And it's running that little collision function that I got from Jeffrey Thompson. And based on what it finds in the collision, if there is a collision, then it goes CR equals 1. And if there's not a collision, then it goes CR equals 2. That's 0. What am I talking about? It's 0. Okay, that's for the first ball. Great. So at the end of that first pass through the loop that we have here, when I is 0, it makes that determination if CR is 1 or 0. But then it goes and it takes the next ball. Let's use green for that one. And it pulls that out of the array, and it checks that ball against the positions of my players, and it looks for a crash. And depending on what it finds, it sets the value of CR to either 1 or equal to 0. CR equals 0, like so, if it does not detect a crash. So one of these two outcomes happens. And that happens after every single ball. So what I think you can see at this point what's going to happen. When I get to the last one, right, the last one ends up being the only one that matters, because regardless of what I've set for this CR variable, 0 or 1, it doesn't matter, because when I check the last ball, when I do this comparison at the end, that's going to be the final value of the CR variable. It's going to be either 1 or 0 coming out of this loop that I have here. And so only the last ball in the array ends up mattering for setting the value of this particular variable, because the value of CR just keeps getting overwritten each time as it passes through element by element in the array. Okay, so that's what's going on. So in that case, I'm not turning the thing red enough times, right? It's only red if the last ball in my array is the ball that's hitting it, right? And that's why you saw the behavior that you saw. So if I go back to the actual file here, let's run it again. Right, so let's see. It'll work if I collide once. Wait a minute now. Let's refresh this page. Okay, let's refresh the page. So here we go. Okay, there's a collision. That works fine. And by the way, this ball will keep colliding. There'll be no problems with it. Let's see if we can get another one. Here we go. Come on. It's the opposite of what you usually want, right, in a game. Trying to avoid collisions with the enemy. Here I'm just trying to get one there. Come on. Unless you're writing snake, right? And then you actually want to collide with food particles. This is absurd. Come on. There it is. Okay, so that one keeps working. Now when I put another ball in, oops, that one works. Great. Let's put a second ball. Now that first one doesn't work anymore. I don't know if you saw that, but the second one works. So only the second ball will show a collision. There it is. Okay, but the first one did not. You saw a couple of passes where it didn't work. Let me put a third one in. That one works. And now only that one works, but the other ones do not. And so it's always the last ball that I put in that will show the collision, right? That one's not the last one anymore. Okay, so I got to fix that. How do I do that? I take this out of here, right? And so a little algorithmic thinking for you. What I want to do is actually, at the beginning of my loop, I'm going to set that equal to 0. So we're going to, coming into this process of checking the balls, or checking the player for collision with any ball, we're going to set that variable equal to 0. And then we're going to iterate through the array of balls, check one by one by one. And if any of them end up crashing or colliding, we're going to set that equal to 1. And then it's fixed. It's 1. Because this whole for loop will run through the whole array of balls before draw gets to do its thing again. And so at the end of this function, when collide wraps up, CR will have a value of either 0 if no collisions were detected, or 1 if any collision was detected. And then it's going to go ahead and properly colorize that ball, that player. Okay, so with that, if I come back and refresh, and let's see, I have an error. Unexpected token else on 71. What did I do? We can't have that. We're not part of an if anymore, of course. So we're just literally going to set that variable equal to 0, sort of assuming at the beginning of collide, every time we enter the collide function, that there's not going to be a collision. And then if we go through, we're like, oh, yeah, we found a collision. It's hitting one of the balls. Then we override that, turn it to red. All right. And then 1/60th of a second later, we assume again, there's not going to be any collisions. Oh, but yeah, there was. We found one. Okay, here we go. They should all collide now. Yep, there we go. Let's try. Let's move them around. Let's put a whole bunch of balls in here. So now every time they collide, we're turning red. All right, so this is the code that I wanted. I think this pretty much does it. Now, if you were making a game out of this, you'd obviously want to do more than turning the player red. There's a whole lot of things that you could do at this point. You could, have a score counter that goes down. You could have a health-o-meter that goes down, or you could just have the player die or something like that. Who knows? And then, of course, there's the whole interaction of these two things. How do you make them bounce off of each other? And I think this video has gotten much too long already, so I'm gonna kill it here. I think I'm gonna make one more of these as a follow-up, which deals with the actual bounce interaction between objects. And I think what I'm going to do with that one is actually take a look at how we'd have the balls collide with each other. How could we make it so that these things actually bounce off one another so that they look realistic? And in order to do that, we have to do a little bit of physical modeling to model what's known as an elastic collision in 2 dimensions. And again, I'm going to pull up some code that I already have, some pre-existing code that I wrote for that, and use that and translate it to JavaScript so that you could see how it is we could have all the balls interact with each other. All right, but I think that's enough for now. That's kind of a quick and dirty, well, not quick, but a dirty method for making collisions happen on a P5.js canvas, thanks to the wonderful math and algorithmic ebook, or whatever you want to call it, of Jeffrey Thompson. All right, take care, and I'll see you again soon.